for the momentum question, as I mentioned in the energy problem from the other day, there's going to be energy involved in this. Momentum and energy tend to go hand in hand. In this momentum question, we have block A with a mass m, slides down this frictionless hill of height h, and it starts from rest. Collides with block B. Block B has a mass of 3m, so triple that of A, and afterwards the two continue to slide across the surface with friction, and friction brings them to rest. And your goal is to answer these three questions in terms of m, h, and fundamental constants. So the first one says, find the velocity of block just before it hits block B. Well, that potential got converted into kinetic. So mgh is 1/2 mv squared. The mass of block A is not important in determining the velocity. The velocity of block A before collision was 2gh. Make sure you use the capital H because that is what's given right here. So moving on to B, it says determine the velocity of the two-block system immediately after the collision. So by conservation of momentum, MAVA plus MBVB equals, and it says the two blocks continue to slide and encounter a surface with friction. We are under the assumption that they stuck together because it says here totally inelastic collision. So we'll do MA plus MB multiplied by V. On the left side, block B was motionless, so that term goes away. The mass of block A is m. The velocity of block A was root of 2gh. Inside here, we have m and 3m v. So this will be 4mv equals m root 2gh. The letter m itself cancels out, and the velocity after the impact would be 1/4 of the velocity of block A prior to impact. And then it says determine the work done by friction to bring the two-block system to rest. Well, the work done by friction is the change in kinetic energy. The initial kinetic energy is a 1/2 mv squared. The final kinetic energy is 0 because it comes to rest. So 1/2. The total mass is 4 capital M. Block A is m. Block B is 3m. 1 plus 3 is 4. The velocity, we'll put the root of 2gh over 4, and we'll square the whole thing. So we're going to end up with, to simplify, the 1/2 and the 4, that's just going to give us a 2. So negative 2m, and everything here over 16 2gh. Simplify a little bit more. This 2 and 2 can reduce this to a 4. And the work done is negative because it took the energy away. Capital M, G, capital H over 4. Victory.